This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there. Welcome to a new episode of the Industrial AI podcast. My name is Peter Seberg, and today all I will do is introduce you to a new podcast interview, which Robert did the other day with Günter Klambauer. Günter is Associate Professor for AI in Life Science at Johannes Kepler University in Linz, Austria, which we have heard of before. As it is the university where also Sepp Hochreiter resides. Günter visited the NeurIPS conference in New Orleans a week or two ago, and he shares an update of the highlights from the conference with Robert. Next week, you will hear Robert and me again, providing you with the latest, greatest news on industrial AI. For now, enjoy listening.
Hello, Günter. Welcome to our podcast.
Hello, Robert. Thanks for inviting me. I'm happy to join this podcast.
Günter, introduce yourself to the listeners briefly. 3 sentences.
Yes. So my name is Günter Klambauer. I'm a university professor for artificial intelligence in life sciences. And I'm doing research in the area of machine learning and machine learning applied to problems in molecular biology, chemistry, and other life sciences.
We are normally not focused on life science, but today we invited you because you were in New Orleans. And how did you like it?
Yes, this was a blast again. And I'm very happy that this was a conference again in a non-virtual format where we could physically go. We've met a lot of great people, lots of machine learning experts, renowned experts joined this conference.
Yeah, Jan LeCun was there.
Yeah, Jan LeCun, he visited even our poster and discussed with us. That was great.
Tell something about these poster stuff, because this is famous for this conference, I think.
Yes. So I think the poster sessions at NeurIPS are much more prominent than at other conferences. So it's a huge success if you get to present a poster. There are close to 5,000 papers submitted and only 1,000 are accepted, or less than 1,000 are accepted for poster presentation. And so you have several huge poster presentations, which means there's a big hall full of hundreds of posters. And at each poster, there is a researcher or a team of researchers trying to present this. And yeah, people are walking through these poster halls like me. And then the interesting posters I approach. And then the authors of this poster, they present and explain what they did in their research. And of course, so we were also presenting one of our research works as a poster. And of course, we were very happy that Jan LeCun and also many others visited our posters, and we could present them our work.
It's not allowed to use a monitor, right?
Yes, you are allowed, but it's difficult to bring monitors. So there was a particular poster. They had a printed poster, a huge one with cutouts, and there they applied, I think, 8 tablets.
Okay.
Yes.
Let's come back to our topic. Did you like it? And which technologies were the focus on and why?
Yes, I liked it a lot. I think there was much more interaction again and a lot of science going on and discussions. And the current technologies that are heavily discussed are, of course, large language models and text image models, besides some other techniques that I will maybe have the chance to talk later. And the large language models are, so for example, these GPT and ChatGPT, this dropped during NeurIPS. These are models that can simulate natural language. They are able to write meaningful sentences or answer to questions. And they are heavily discussed not only technologically, but also with their implications for technology and society.
You mentioned ChatGPT. What is your opinion on ChatGPT?
For me, it's like other large language models. It is very good at producing text that is plausible, but it's not very good at, for example, like reasoning or memorizing stuff. So it's something like pretending. It's a person that pretends like to be involved in these issues and so on, and you can easily trick it, and it makes a lot of errors. But from the scientific perspective, to get to this level of having a machine learning model, a neural network producing text of that quality is of course a great success. but it's completely over-exaggerated, for example, to mention that these large language models have any form of consciousness.
But that's maybe a topic for the research in the future.
Yes, of course. So there was a talk by David Chalmers, only focused on finding out or shedding the light on whether large language models could be conscious and on consciousness from different sides. So I think putting that aside, the large language models in science and research, they will continue to be relevant. People will come with other models. So currently these are mostly transformer-based, whatever that is, and they get better and better when you scale them up. Although the first research works already show that we have diminishing returns on scaling. So if you make them larger and larger, you get improved quality, but by making them now double as large or so, you see diminishing returns. So it doesn't improve as much as before. And also Sepp Hochreiter, one of the inventors of one of the first, so before the transformer-based language models, we had LSTM-based language models, and Sepp Hochreiter is the inventor of the LSTMs. He gave a very exciting talk, and he commented also on large language models and said that they, within their billions of parameters, they memorize things and texts explicitly, like addresses, which is stupid. And this went so far that Sepp Hochreiter even said deep learning sucks.
Because deep learning sucks.
Because of this basically wrong usage. The increased parameter or the large language model, where the word large is used, means that they have so many adjustable weights, adjustable parameters, that they use that to store text parts, basically. And there should be other mechanisms to store and retrieve individual text parts. But that's, we're diving into science now.
Yeah, but that's very interesting. So ChatGPT and large language models, okay, one very important topic. What else, Günter?
Yeah, I would say still in connection a bit with that. So text-image models, meaning you have a text prompt that generates an image. And there are also many models doing that. I think it's related, but people are thinking now, how can we calculate how good these generated images are and thinking about such things. But there's a huge other trend aside from that, and which is about new learning paradigms. That is, for example, one of the invited talks was by Geoff Hinton, and he proposed a forward algorithm. And this is basically a method to train so we say the large language models, they are neural networks, and we say we train them. So we have a huge amounts of data, and on this data, we train them, meaning that we adjust their parameters. And for a long time, there was a single training paradigm saying that we have inputs and we have labels for that. Imagine you have a database of images or a million of images, and for each image, you know the image class, like cat, dog, ship, airplane, and so on. And then you train your neural network to respond with the correct image label or label in general. And this is so-called supervised learning, very standard supervised learning. And the weights were adjusted by backpropagation. So that is a mathematical technique, taking the derivative of so-called objective function and then gradually adapting the weights. And Geoff Hinton said that this backpropagation algorithm, this cannot be the thing that is done in our brain by our neurons. And we should have other more efficient things that learn differently. And so he said, not before we did forward pass and then a backward pass, we should do 2 forward passes. And it's a bit technical, but he explained how by that this can be learned. But not only he is looking for new learning paradigms, also others like Jan LeCun, he suggested energy-based models that are regularized and focus on positive pairs and so on. So people are looking for new objective functions, for new ways to generate supervised data, which we call self-supervised learning. People are looking for so-called contrastive learning objectives. So these are new learning paradigms.
That sounds a little bit like reinforcement, or I'm wrong.
Yeah, no, reinforcement learning, I think it's related, of course, but this is still without an environment with which you can interact. So in reinforcement learning, good question. So you always have an agent that can interact with an environment. So think of a computer player playing a game or a chess player playing the game. So the game is the environment. You do something, then you get some feedback. But here we're still talking about just you get a data set and you have to learn something on that. And it's also right that we should change our learning paradigms because we humans also, we learn a lot unsupervised. So when we when babies learn something, they're not always told by their parents, this is a dog, this is a tree, this is a table or whatever, but they learn a lot by just observing. And that's currently not, and that's very efficient. And that's not how the neural networks, how the large language models currently learn. And therefore, we could probably improve AI's machine learning by coming up with new learning paradigms.
That's very interesting because my co-host Peter always says that reinforcement learning is very near how humans are learning. And you say, no, that's a different perspective, right?
Yes, because we humans, I don't think we learn a lot by trial and error. So you go around and you try something and you fail and then you adapt your strategy. But that's not the usual. I think we have a lot of knowledge about the world by just looking at it. If we see an object from different perspective, we know this belongs together. We see babies see someone, they don't know even how to move their hand, but then they move the hand and this hand moves another object, and then they have just, whether it's good or bad, they just, I don't know, maybe they intrinsically generate some reward, but still we're just observing without any strong feedback, this was good or bad. We know how things work and which things belong together and what are objects.
I think this observe is very important because we learn a lot while we observing a situation also. Yeah.
And also temporarily, for example, we think that temporarily are close together. So we think often that this belongs together. If I move this glass on the table and suddenly it dropped, this must have something to do with my moving of the glass. Then suddenly it started to drop. So I think, it's not only reinforcement learning, definitely.
What will this approach change?
I think it's a bunch of approaches, and it's unclear at this point which new learning paradigm will take over. 2021, I always say, is the year of contrastive learning, contrastive loss. There were many successes. For example, this contrastive learning.
Can you explain for our listeners what is it?
Contrastive learning from last year, for example, the CLIP algorithm. This was the first time you could embed text and language in the same embedding space. And this allowed for all these text image models where you can start a text prompt and generate an image. And this was allowed by contrastive learning from last year. And this is already changing a lot. So how people interact with AIs is now enabled by text because we have a common embedding space of images and text. So this has already changed a lot. New learning paradigm, contrastive learning has already changed a lot and will continue to do so. It could be. So if I'm very sure that this would allow in many ways that humans interact with AIs by natural language, meaning to tell the AI by just in text to this and this, but also like the output of an AI system, maybe so the AI does something, steers something or finds something out. And it's often it's often completely different coded in the AI, what it does, for example, which action it takes. But at the same time now, AIs might be able to write out a small text saying, okay, I now changed my strategy. I went over there because I saw this and this. So all these interactions with AI systems, with machine learning systems, but also other AI systems could now be enabled with having text and natural language as interface, basically.
Günter, everything is very, very interesting. Now my question, because our name is Industrial AI Podcast. We are talking about industrial AI. What can we learn from these approaches in the industry?
So I think industry is also one of the main profiteers, I think, of new AI systems. So I think this would help a lot by interacting in industry, for example, with text and having natural language as interface. I think there is a lot of improvement. And in general, improvements, for example, in image recognition, text. I mean, images can be taken anywhere when you, for example, produce some products and you can check them by a camera and then find potential problems. This has improved also now with the new architectures for image recognition. But I think beyond that, I think we will have, and this is another trend I wasn't able to talk about, we will have a kind of, I would say, bilateral AI systems.
What was the name?
Yeah, I call it bilateral. You could see neurosymbolic AIs. There's a lot of work on how machine learning can interact with symbolic components, with discrete structures. And I think there are a lot of already great, for example, symbolic AIs or symbolic checks, symbolic procedures in place in industry, but they are not at full capacity. And now there's a lot of new research going on how to combine machine learning with symbolic AI. And this is another exciting trend that I can now mention. And this will also have an effect on industry, where these currently established, maybe some symbolic AI systems are already running, and they can be empowered by machine learning systems.
I highly recommend our episode with Festo. That's a German automation company. Maybe you know it. And they are working exactly on this topic to combine these two worlds. Or is it one world? We don't know. Jürgen Schmidtwiller would say it's one world and not two worlds. What is your opinion? Is it one world or two worlds?
It's one world, but currently these two scientific areas are two worlds, or mostly two worlds. So I know that, so also historically, this AI, symbolic AI research community and the machine learning communities were quite apart. And you also see that because we started with talking about NeurIPS, it's neural information processing system that was about neural networks, then machine learning, and you could hardly see any symbolic AI. And then also the symbolic AI persons, they have their researchers, they have their own conferences. So in the next years, in order to advance to a new level of AI systems, these two communities have to get together and form AI systems that work in this one world that needs both. And in that connection, I also want to mention that there is a lot of research work and a research trend now going on causality. So people try to develop models that are able to find causal reasons for people or for things happening and to identify causal features. And this is a huge trend that also will affect industry, I think.
Let's come back to the conference. What did you present? What was your topic?
Yes, good. It's about the contrastive learning objective and paradigm.
Okay.
So this famous CLIP algorithm that changed everything from 2021, it feels very old now, actually, although it's only a year old. So this CLIP model, contrastive language image pre-training, I've talked before, this enabled to embed natural language and images in the same embedding space and allowed for this text-based generation. We improved this strongly by our method CLOOP, C-L-O-O-O-P, sorry, a contrastive leave one out boost. And yeah, it's a bit technical. Basically, we use a memory-based system to enrich. So you have an example, think of an image, and before you compare it with the text, which is done by CLIP, you first enrich the image by looking at other images. For example, you have an image of, let's say, a horse, and then you look at other pictures of horses and see what is common for horses, how do horses look on other images, and only then you compare it with the text. And this gave a strong improvement over the CLIP algorithm.
That's very interesting. And how was the reaction of the visitors?
Yes, so overall we got extremely good feedback. The poster was crowded for more than 2 hours of the poster session. Also, Jan LeCun was there and was very interested. He was thinking about something very similar. So we did actually 2 changes to the CLIP algorithm. And one of those changes with this objective function, whatever that is, he also had suggested in one of his papers almost simultaneously. And therefore he was very interested. Although in general, he gave also a talk, Jan LeCun gave also a talk and said the community should abandon contrastive learning methods for regularized methods. Also one of the statements that is very broadly discussed, and I do not support actually, but yeah, it's his scientific opinion, of course, and that's also very, very valuable.
So it was a great conference.
It was overall, it was a great, exciting conference.
And you weren't sick because many had spoiled their stomach.
I did not get COVID or any other diseases. At least until now, I'm fine. Although my flight got cancelled, so I had some troubles coming back. I'm here. I'm back in Austria now.
Günter, it was a pleasure to talk to you. Thank you very much.
Thanks, Robert.